Welcome to the lair of the Batty Boffin.
Hi there Batty fans, there's a little bit of exam practice again today and we're doing higher level GCSE exam questions with the Batty Boffin, helped as ever with Bathilda the Batty cat. Now today she's in her car again and she's putting her car away into her garage. However, when she's finished she fancies having a game and so she pops up to the roof of her garage, which is handily very flat, and she notices that it is a perfect rectangle. The area of that rectangle is 10 square metres and she fancies doing a bit of a running around, and she notices that the longest length of the diagonal of the roof is root 29 metres. So from corner to corner of the roof, which is a flat rectangle, is root 29. So all you need to do now is please work out the dimensions of the roof. Okay, let's have a work through that. Clearly we're going to have a bit of Pythagoras going on in here because we've got the length of a diagonal. So I'm just going to sketch out the roof here as a rectangle. So here's our roof and here's our diagonal, which we're told is root 29. So hopefully seeing square roots and diagonals of rectangles should make you think Pythagoras. I'm going to call that side x and that side y, and we're going to write down some equations. Right, first thing with Pythagoras, we know that x squared plus y squared equals root 29 squared. Okay, root 29 squared is 29. Okay, so that's our first equation. X squared plus y squared equals 29. Secondly, we know from the area that xy is 10. Now that's two equations and two unknowns, so we can solve those by simultaneous equations. Now it's not your normal type where you've got so many x's and so many y's and stuff like that, and you can just balance them up, because we've got x squareds, y squareds, and we've got xy's and things. So we're going to solve this one by substituting in. What we're going to do is rearrange one of the equations so that it says x equals or y equals, shove it into the other equation, crank the handle, and the answer should fall out. Right, I'm going to rearrange this one and I'm going to make it say y equals, dividing both sides by x, 10 over x. Okay, then I'm going to substitute that one into there and let's see what happens. Okay, so I'm going to rewrite this, but every time it says y, I'm going to write that instead. So we're going to get x squared plus 10 over x squared equals 29. Okay, that looks a bit scary, doesn't it? Well, let's multiply that out. Okay, 10 over x squared, just to save time I'm going to do this here, becomes the 10 squared, which is 100, over the x squared, which is x squared. Okay, right, now we've got something on the bottom of the fraction which is generally a bad idea. So let's multiply through by whatever's on the bottom of the fraction. So multiplying through by x squared, we get x to the fourth. I'll try that again. We get x to the fourth plus 100 equals 29x squared. Okay, believe it or not, that's actually a quadratic-ish. Let's just rearrange it a little. X to the fourth minus 29x squared plus 100 equals 0. Okay? It might not look like a quadratic because it's got the fourth in there, but actually if you take x squared as being your thing, that's x squared squared plus a certain number of x squared plus something, so it's kind of like a quadratic. Right, I'm going to do one of the things where it goes back and comes back again because I need to wipe down the board back in a second. Right, that's given us a little more room. Here's our equation that we had on here, and to make it maybe look a little bit nicer for you, what I'm going to do is I'm going to do a quick substitution of having capital X be x squared. Okay, so that is x squared squared, so that's capital X squared minus 29 capital X plus 100 equals 0. That now looks a bit more like a quadratic. So for a quadratic we need two numbers that multiply to make positive 100, and when you add them you get negative 29. Well, we've just got a plain old x at the beginning here. Two numbers that multiply to make positive 100 and add to make negative 29. Hopefully 4 and 25 should spring to mind. If we make both of them negative, so negative 4 and negative 25, negative 4 times negative 25 is positive 100, and that's going to give us negative 25 capital X's and negative 4, which is going to make the 29 there. Okay, so we've got that there. You could, incidentally, if you didn't do the substitution, you'd have ended up with little x squared minus 4 and little x squared minus 25 equals 0. Both of those are fine. We solve those, and we end up, I'm going to have to rub this off again. Okay, here are our solutions given in capital X's or little x's. If you did it in capital X's, then you just substitute back in again. So we've got x squared equals 4, which gives us a value of x of plus or minus 2, or plus or minus 5 from here. Now clearly we don't want the negative ones. You can't have negative lengths of things. So the answers are x is 2 metres or 5 metres. Of course we know that x times y is 10. That's supposed to be a times there, that is. X times y is 10. So x equals 2 gives you a y equals 5. And x equals 5 gives you a y equals 2. So whichever way round you do it, it ends up being a 2 by 5 rectangle. Okay, I hope you had some fun with that. That was quite a nice one, that. I like doing simultaneous equations, are a little bit different from the normal. I'll see you next time for a little bit more exam practice. Bye for now, Batty fans.
Mwahaha! Mwahaha! Mwahaha!